Hello guys, welcome back to my YouTube channel, and for today's video we're going to tackle chapter 8 in the NetAcad, which entitled Subnetting IP Networks. So designing, implementing, and managing an effective IP addressing plan ensures that a network can operate effectively and efficiently. This is especially true as the number of host connections to a network increases. Understanding the hierarchical structure of the IP address and how to modify the hierarchy in order to more efficiently meet routing requirements in an important part of planning an IP address scheme. So let's go try and answer some activities in chapter 8 for more ideas and for better understandings. So our first activity is entitled calculate the subnet mask. Then the instructions here is in this activity you are given a subnet mask in decimal format. Enter the binary representation of the subnet mask in the octet fields provided. Additionally, convert the mask to prefix notation format in the prefix notation field. So here, let's get started to answer this activity. So the first problem that we are going to answer is 255, 255, 255, and 248. So we all know that the 255 contains 8 ones, 8 ones, and then 8 ones. And lastly, we're going to calculate that will come out, the answer will be 248. So let's calculate it. First, 128 plus 64. So 192. Still do not close to 248. So we will enter here 2 ones, then plus 32. Still not in the 248. So we'll enter 1. And then plus 16. So still not in the 248 value. So next is plus 8. So here, now that we get the 248 value, so the remaining slot for the bit will be 0. And here, in the prefix notation, we're just going to count how many ones or bit are there in the subnet mask in the binary. So here, this set will be 8, then 16, 24 plus 1, 2, 3, 4, 5. 1, 1, 2, 3, 4, 5. So this is 5, to 24 plus 5 is 29. So that is the correct answer. So let's try another problem. So here we are up to 255, 255, and 255 again. This is 8 1, 8 ones, 8 ones, and then we will try to calculate to get this value. So first, let's start in 128 plus 64. So that's it. So we already got the value that we wanted. So we will enter 1 1, then the remaining slot will be 0. Then the prefix notation, we will just going to count how many ones in the binary subnet mask. So this is 8, then 16, 24 plus 2 will be 26. So that's it. So we're going to try this another problem for the last time. We're going to answer. So here, 1, then 8 ones, and then this will be all 0. since it doesn't have value. So 240. So I think we already compute for that value, and this is 51, 5, and then 3 zeros. So the prefix notations here should be 16, 16 plus 5 should be 21. Let's try this again. 128 plus 64 plus 32 plus 16. It should be 41 and 40, and the answer should be 16, 16, 1, 2, 3, 4, 20. So that's it. So that's how you calculate the subnet mask. So let's proceed to the next activity. Here in this activity, which is entitled determine the number of bits to borrow. So the instructions here should be, in this activity, you are given the number of hosts that are needed. Determine the subnet mask that would support the number of hosts as specified. Enter your answer in the binary, decimal, and prefix notation format in the fields provided. So let's start answering this activity. So here we are given a 25 hosts needed. So in this activity, you should remember the formula 2 raised to n, which is n is meaning that is the host. No, the bits need to be borrowed. So here 25, we need to get a value that is higher than 25 but not less than 25. The So let's proceed to the calculator and find the first greater than number than 25. 2 raised to 5, 32. So our bits borrowed should be 5, and that will be subtract to our default prefix station, which is 32 rather. So 32 minus the bits borrowed, which is 5, so it's 27. So we get the prefix notation here should be 27. Then this when you get this prefix notation, you can answer now the subnet mask binary part. So here 27/27 means you need to enter here 27 once. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 24, 25, 26, 27. Then the rest will be 0. So after you fill up the subnet mask binary column, next will be subnet mask decimal. So we will convert the decimal, the binary, the subnet mask binary to subnet mask decimal. So in order to do that, so we're just going to convert this part into the decimal, since we know that 8 ones should be 255. 255, 255, 255. So 1 we're going to compute 128 plus 64 plus 32. So 224. So our subnet mask decimal should be 255.255.255.224. Yeah, so let's proceed to the next. Here we are given a host needed, which is 1000. So we're going to compute again host network that that is greater than 1000. So let's use again the formula, 2 raised to n, which n is the borrowed bits. 2 raised to, let's say, 2 raised to 10. So 1024 and 1000. So this should do it. And remember the number that we raised to the power. So our borrowed bit should be 10, and we will subtract it to the default prefix notation, which is 32. So 32 minus 10 is 22. So our prefix notation in this part is 22. And then like I said a while ago, this represents the number of ones that will in the subnet mask binary. So we will enter here 22 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Then we will stop there, and all of the remaining bits will be 0. And then after that, we were going to convert it to subnet mask decimal. So we will just compute this part, and we all know that this part will be 0. So this is the important part here. So we're just going to compute it. So we have uh, wait, 1, 1, 2, 3, 4, 5, 6. So we have 6 1 here. Should be 128 plus 64 plus 32 plus 16. 1, 2, 3, 4, 5 plus 8. So let's try to compute this. And 128 plus 64 plus 32 plus 16 and plus 8. So 248 will be the answer. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Let's try and add. It should be 1, 2, 3, 4, 5, 6. So 6 ones, and we need to add more 4 plus 4, then 252. So here the answer will be, the subnet mask decimal should be 255.255.252.0. So the next host needed will be 75. So we'll just repeat the process. So we'll just going to find the host greater than 75 but not less than to it. So we'll just try to 2 raised to 6, 64, no, 2 raised to 7, 128, no, 128, 2 raised to 6, 64, 2 raised to 7, So it is 2 raised to 7. So our bits borrowed should be 7. Then we will subtract it to 32. 32 minus 7, 25. So our prefix notation is slash 25. Then we will enter here 25 once. 16, 24. The remaining will be 0. So here we will just convert it to the subnet mass decimal, which is 255. 255 that 128. 128. 128. So next is the host needed will be 10. Then we will compute again. 10 raised no, 10 raised to 4. So this should do it. 16. So the borrowed bits that we needed here is 4. So it will be subtracted to our default prefix notation, which is 32. So 4 minus 32 is 28. Then now that we acquired the prefix notation, we all know that there are 8 ones here in the subnet mask binary. So 8, 16, 24, and we need more 4 because 28 is our prefix notation. 1, 2, 3, 4, then 0. All of it will be 0, 1, 2, 3, 4, 4. Then we will compute this part. 1, 2, 3, 4. 1, 2, 3, 4. 4 ones. So we'll just keep adding. 128 plus 64 plus 32 plus 16. 240. So to ensure that our answer is correct, so 1, 2, 3, 4, it should be 128 plus 64 plus 32. 1, 2, 3, 4. 1, 2, 3, 4. 32 plus 16. 128 plus 64 plus 32 plus 16. So the answer will be 240. So 255, 255, 255, 255. That the answer is 240. And lastly, the host needed will be 500. 500 should be 8 to raise no 2 raised to 9. So 512, they should do it. So our borrowed bits is 9, and then we're going to subtract it to our default prefix notation, which is 32. So 32 minus 9 is equals to 23. So our prefix notation here will be 23, and then 23 once 6, 17, 18, 19, 20, 21, 22, 23, then 0. Then let's convert it to subnet mask decimal. 255 or 255 that 255 Here will be 7 ones. So 128 plus 64 plus 32 plus 16 plus 8 plus 4. 1, 2, 3, 4, 5, 6 plus 2. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So the answer here should be 254. 254, then 0. Since this is part is 0, so I hope I got the correct answer here. So let's go check. So that's it. So that's how you determine the, or rather to compute the prefix notation and how to convert a binary to subnet mask decimal. So let's proceed to the next activity. So in this activity there are two parts here, which entitled here's the part 1 and part 2. So of course we're going first to answer the part 1 entitled practicing VLSM. So the instructions here should table 1 uses regular subnetting to accommodate the network shown. Table 2 uses BSLM to further subnet the network. Drag the addresses to the appropriate subnet descriptions. So here's the given IP address and the user per the calculate the 50 users per subnet. So the first questions here is new subnet mask. So we're going to determine it. So our given user per subnet is 50. So just like the previous activity, we're just going to find a number which is greater than 50 using the formula. So 2 raised to 5, 32, no, 50, 2 raised to 6, so 64. This should do it. So now that our borrowed bits is 6, we will minus it to our default prefix notation, which is 32. So 32 minus 6 is 26. So we know that we have now 6 1 in the binary. Rather, we have 26 ones in the binary. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And this makes 16, 17, 18, 19, 20, 21, 22, 23, 24. Then 25, 26. And the rest will be 0. 1, 2, 3, 4, 5, 6. Here we're going to convert it to decimal subnet mask. So 8 ones, 255, 255, at 255. And then it should be 128, 128 plus 64. So let's compute it. 128 plus 64 will be 192. So here should be 192, and this is the answer. So let's find it in the choices. 255.255. So here's the new subnet mask decimal. So we all know we already computed for the prefix notation, which is we minus our borrowed bits, which is 6, then to default prefix notation. So that's what we come up to this 26 prefix notation. So this should be the answer. And the first full subnet range, we would be based on this IP address, which is closer. So this is a 192.168.5.0/24. So we're going to look closer IP address here. So this is it. It should do it. Then the second full subnet range is which next close to this full net subnet range. So here is 63 and 0, 63, 64, 63, 64, 127, and then 192, 264, 255 to 127. So let's check if we arrive in the correct answer. So we got it correctly. So let's proceed to part 2. So this part 2, we have here the use the table second full subnet branch and BLSLM to calculate for 20 users per subnet. So we are given here 20 users per subnet, and the first we need to identify here is second full subnet range slash range from table 1. So we're going back to the table 1, which our second full subnet is 192. So this is it, the answer. Just going to find it. 192.164.592.27. So this is the answer here. Next we need to identify is the new VSLM subnet mask decimal. So we're just going to repeat the process. We're just trying to calculate a number of host subnet greater than 20. So I think it should be 5. Oh, sorry. 5, which equals to 32, and that should do it. So our borrowed bits should be 5, and we're going to subtract it to 32. 5 minus 32 equals to 27. So now we get the representation 27. That should be the answer here, and we will compute for the subnet mask decimal. So we have 27 ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 0, 0. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4. 0, 0, 0. And now we're going to convert it to decimal. 255, 255, 255, 255, and then 128 plus 64, 64 plus 32 plus 16. So we're going to compute here to get the answer. So 128 plus, let's remove these 3. 128 plus 64 plus 32 plus 16. So the answer will be 240. 240. So the decimal subnet mask would be 255, 255, 25, 27, 24, 40, 45, 25. This 24. This should be 224. Mistype. So this will be the answer. And then we will going to base here again. So this which is closer. So 5, 64, then 127. So this is the full BLSM subnet mask range, and then the 192.179. So let's check if we got the correct answer. So that's it. So we managed to answer all of the activities here in the chapter 8. So if you like this video and if you learn, please like and share and subscribe. So thank you for watching.